Today we start with a new chapter, chapter number 3, pair of linear equations in two variables. Okay, so in this lesson I will introduce this chapter and we will discuss some previous knowledge. Okay, so in 8th standard you have studied linear equations in one variable. Linear equations in one variable. Can you say one example for a linear equation in one variable?
2x plus 3 equal to
2x plus 3 is equal to
4.
4. Okay, 2x plus 3 is equal to 4. This is linear. The degree, the highest degree is 1. If the highest degree is 1, the equation we can call as linear. And this is only one variable here. So this is a linear equation in one variable. And in 8th standard, you have also seen the solutions of the linear equations in one variable. Now you can shift the numbers into right side, the coefficients and constant term. Then you will get the value for x. And in this example, 2x is equal to 4 minus 3. So 2x is equal to 1 and x is equal to 1 by 2 is the solution. So for a linear equation in one variable, we have studied that there will be only one solution for the equation. Only one solution. Okay. So next is in 9th standard you have studied linear equations in two variables. Linear equations in two variables. So can you say one example for linear equation in two variables?
2x plus 3y equal 5.
Yes. 2x plus 3y is equal to 5, right? Okay, 5. Okay. So this is an example for linear equation in two variables. So x and y are here. X and y are variables and 2, 3 and 5 are constants. Okay. So similarly you can give many examples. Okay. And in 9th standard you have seen how to draw their graphs. How to draw the graphs of linear equations in two variables and how to find the solutions. How to find the solutions of a linear equation in two variables. Okay. So before that, what's the general form of a linear equation in two variables? General form.
Ax plus by
ax plus by equal to
Ax plus by is equal to
c.
C. Okay.
But we prefer to write the constant term on LHS. So the general form of a linear equation in two variable can be written as ax plus by plus c is equal to 0.
So this is the general form of a linear equation in two variables. And here a, b and c are constants and x and y are variables.
There is a condition for the coefficients. A and b are not both 0. That means at the same time a and b cannot be 0. A can be 0, b can be 0, but not at the same time. In mathematics, this condition can be written as a square plus b square not equal to 0. You look, a square and b square are square numbers. They cannot be negative, right? So their sum cannot be negative. But the sum can be 0 or positive number. When will be the sum as 0? A square plus b square is equal to 0. That is in the case when a and b are 0. So avoiding that case, we will get this selection, right? So we can write a square plus b square not equal to 0 for the condition a and b are not both 0.
Okay, so this is the general form. So I start with a very simple example. X minus y, c I take as 0, c equal to 0. So here in this example, what is the value of a?
1.
1. What is b?
Minus 1.
Minus 1. What is c?
0.
C is 0. Okay. So a is 1, b is minus 1 and c is equal to 0. And here Is this a linear equation in two variable? Any doubt?
No.
No. Okay. So if you want to find the solutions of this linear equation in two variable, how can we find? How many solutions are there? Only one or more? And how we can find?
One. Only one.
Only one.
No.
Only one is more.
Many solutions are there, right?
Many solutions.
Two.
Infinite numbers of solutions are there. For a linear equations in two variables, there are infinite numbers of solutions. You have studied in 9th standard. And we write solutions as pairs. If it is a question in two variables, the solution we write as a pair. Okay. So here you can see if x is equal to 1. So if x is equal to 1, what will be the value of y? If x is equal to 1, what will be the value of y? Question. Y should be 1, right? Because it will become y minus, because when x is equal to 1, we substitute, this will come 1 minus y is equal to 0. Therefore, you can move minus y to right side. So 1 will be y. So y is also 1. And in this case, we will say that x is equal to 1, y is equal to 1. That is 1 comma 1 is a solution of this linear equation. 1, 1 is a solution of x minus y is equal to 0. Okay, suppose x is equal to minus 1. What will be the value of y?
Minus 1.
Equal to minus 1, what will be the value of y?
1.
No,
1.
no, no,
1, right? So
no.
Minus 1.
Minus 1, right? Okay. So you substitute x is equal to minus 1 in the equation. So minus 1 minus y is equal to 0. In this minus y you take to right side. So if you move minus y to right side, it will become plus y. So y is also minus 1. So when x is equal to minus 1, y is also minus 1. So minus 1 is a solution. Can you say one more solution?
0, 0.
0, 0 is a solution, correct? Any other?
2 minus 2.
No, that's impossible. Here you will get a pattern here. 1, 1, minus 1, 0, 0. If you substitute any value for x, you will get the same value for y. Then only if you subtract, you will get 0, right? A quantity minus another quantity is 0 only if both quantities are same. So in this equation, x and y are equal for any solution. Okay, so here 2 is a solution, 3 is a solution, and suppose a and b, a is a solution, b is a solution, and a and b are some real numbers. Okay, so how to draw this graph? So to draw a graph, you already studied in 9th standard linear equations. The word comes from the word line. Okay, so the linear equation will be as a straight line. Okay, so if you want to draw this graph of this linear equation, you want to draw x-axis and y-axis, then mark points 1, 2, 3, etc. And I want to put at least 2 points, 2 solutions on the plane. You can choose better 0, 0. You can point here, and 1, 1. Any 2 you can mark here. So I mark 0, 0 and 1, 1. Okay, and simply join these 2 points. You will get the graph of x minus y is equal to 0. Join these 2 points with a line. You will get the graph of x minus y is equal to 0. And here in 9th standard, you also studied that the relation between solutions and the points on this graph. Okay, so here we have seen some solutions here. 2 is a solution, 3 is a solution, minus 1 is a solution. All the solutions, every solution are a point on the graph. Every solution of a linear equation are points on the graph. So 1, 1 is here, 2 will be here, and minus 1 will be here. Every solution will be on the graph. And also any point on the line, if you take the coordinates, that will be a solution for the equation. So vice versa, you can say in both directions. If AA is a solution, or you can say AB. If AB is a solution, then AB will be a point on the graph of a given linear equation. And if there is a point, if there is a point Mn on the line of given linear equation, then we can say that Mn is a solution of the given linear equation. Okay, in both way we can say, if AB is a solution, then there will be a point on the graph. And reverse, if Mn is a point on the graph of given linear equation, then Mn will be a solution.